On July 1st, 2025 inches, the remote Chilean highlands, a routine scan by the Atlas Survey telescope, captured something extraordinary drifting into our solar system from the direction of Sagittarius. And at first, it seemed unremarkable. Just another icy visitor from the void, another celestial wanderer passing through our cosmic neighborhood. But as the weeks turned to months, and as the world's most powerful telescopes trained their instruments on this object, designated 3, I Atlas, meaning the third confirmed interstellar visitor ever recorded, scientists began to realize they were witnessing something that defied every natural explanation, something that challenged the very foundations of cometary physics, and something that would force humanity to confront a question we have asked since we first looked up at the stars. Are we alone? And is this object, now racing toward the inner solar system at hyperbolic velocity, a messenger from another civilization? October 18th, 2025, the Keck II telescope in Hawaii, one of the most advanced optical instruments ever built, released spectral data that sent shockwaves through the astronomical community. The analysis confirmed what researchers had suspected but hoped was an error. 3. Atlas is actively venting approximately 4 grams per second of a nickel-based alloy commonly used in the aerospace industry, with no corresponding iron signature. And according to Harvard astrophysicist Dr. Avi Loeb, this was never observed for any other object in nature, not in any comet, not in any asteroid, not in any celestial body ever studied in the history of astronomy. The implications are staggering, because this alloy nickel tetracarbonyl is a compound that has only been observed in industrial contexts, in factories, in manufacturing plants, in the coating processes used to harden spacecraft components. It is a human invention, or so we thought. And now, here it is, bleeding into space from an object that originated light years away from a visitor that has traveled through the freezing abyss of interstellar space for possibly millions or even billions of years, carrying with it a chemical fingerprint that matches our own advanced technology. Thank you for being with us. Subscribe, leave a like, share this video, and leave a comment. But the nickel emissions are just the beginning of the anomalies that have turned 3I Atlas from a curiosity into a phenomenon that demands answers. On August 2nd, 2025, the 2-meter twin telescope at T-Day Observatory in the Canary Islands captured 159 exposures, each 50 seconds long. And the images revealed something that should not exist. According to known physics, a faint jet extending approximately 6,000 kilometers from the nucleus of the object, pointing directly toward the sun. And this is not how comets behave. When a comet approaches the sun's solar radiation and solar wind push gas and dust away from the nucleus, creating the iconic tail that streams behind the comet as it moves through space. The tail always points away from the sun. It is one of the fundamental observable behaviors of comets, a rule as reliable as gravity itself. But 3I Atlas is breaking that rule. Its so-called anti-tail is aimed sunward, like a searchlight, like a beacon LI, key something that is not being pushed by the sun but is actively projecting toward it. And earlier on, July 21st, 2025, the Hubble Space Telescope had captured the same phenomenon an extended glow pointing within 10 degrees of the Sun object line. And if that jet were oriented sideways, researchers calculate it would appear 10 times longer, which implies an extraordinarily powerful directed outflow, something more akin to propulsion than passive outgassing ducted propulsion. Avi Loeb, in his analysis published October 17, 2025, asked two critical questions. What is the nature of the antitail, and why are comet experts ignoring this anomaly while insisting that 3I Atlas is a familiar comet? These are not rhetorical questions, because the existence of a sunward jet on an object of this size and mass is physically unprecedented. It suggests either a completely unknown form of cometary activity driven by exotic surface chemistry and volatile distribution, or it suggests something far more unsettling, that this is not a natural process at all, that what we are witnessing is a controlled emission, a directional thrust, a technology. And then there is the orbit itself. When 3. Atlas was first detected, astronomers quickly determined that its trajectory is hyperbolic, meaning it is not bound by the sun's gravity. It came from interstellar space, and it will return to interstellar space. But what made researchers pause was the orientation of that orbit. The orbital plane of 3I Atlas lies within approximately 5 degrees of the solar system's ecliptic, the flat plane in which all the major planets orbit. And for a random interstellar object arriving from any direction in three-dimensional space, the probability of such an alignment is less than 0.2%. It is the astronomical equivalent of throwing a dart from across a football field in the dark and hitting the bullseye. And it gets stranger because the object is moving retrograde, meaning it is traveling in the opposite direction to the planets, and yet its path will bring it close to Venus, close to Mars, close to Jupiter. A trajectory that Avi Loeb calculated has a probability of just 0.005% for a random interstellar interloper. And Loeb stated it might have targeted the inner solar system as expected from alien technology. Now, some scientists have pushed back. Richard Moisel, head of planetary defense at the European Space Agency, told the press there have been no signs pointing to non-natural origins of 3I Atlas in the available observations, and Colin Wilson, ESA project scientist for ExoMars, described the object as a time capsule from a different era, finding the natural explanation more interesting than speculation. But these reassurances were made before the nickel emissions were confirmed, before the full extent of the antitail was documented, before the polarimetric data revealed another layer of mystery. Because on September 10th, 2025, an international team of astronomers published measurements of how 3I Atlas scatters light, and the results were described as unprecedented. The object exhibits extreme negative polarization, reaching -2.7% at a phase angle of just over 6 degrees, combined with an unusually narrow range where this effect occurs, and a very early inversion of polarization as the viewing angle changes. And to understand why this matters, you need to know that when sunlight hits any object in space, it bounces back in patterns that act like a fingerprint, revealing details about surface composition, texture, grain size, and structure. Every type of asteroid, every type of comet, every category of space rock. has a characteristic polarization, signature, and scientists have catalogs of these signatures built up over decades of observation. And 3, Atlas, does not match any of them. Not asteroids, not comets, not the previous interstellar visitors Oumuamua, and 2, I Borisov. Not even the distant icy bodies in the far reaches of the solar system, the only objects with somewhat similar properties, and even then not close, are certain trans-Neptunian objects. But 3, I Atlas, exceeds even those measurements, displaying a combination of polarization properties that, according to the researchers, is unprecedented among asteroids and comets. It is as if the surface of this object is made of materials or has textures that do not exist naturally in our solar system, or perhaps in any solar system. And then there is the mass. On September 25th, 2025, Avi Loeb and his team published an analysis of the object's trajectory, specifically its non-gravitational acceleration, which is the extent to which outgassing from the surface can push the object off its purely gravitational path. And they found that this acceleration is surprisingly small, less than 49 feet per day squared. And by comparing that tiny push to the known rate of gas and dust loss from the surface, they were able to calculate a lower bound on the object's mass, and the result is staggering. 3, I Atlas must weigh more than 33 billion tons, with a solid nucleus diameter exceeding 1 miles. And this makes it 3 to 5 orders of magnitude more massive than both Oumuamua and 2, I Borisov. The previous interstellar visitors, it is described as anomalously massive, far heavier than an object of its brightness should be. And this raises a disturbing question. If it is so massive, why is it so dim? What is it made of? And why is such a large, dense object emitting industrial alloys and projecting a jet toward the sun? Now, all of these anomalies, the nickel emissions, the anti-tail, the improbable orbit, the unprecedented light polarization, the anomalous mass, each one individually, could perhaps be explained away as an unusual but natural phenomenon. Comets are diverse and interstellar comets. Coming from entirely different stellar environments might exhibit strange properties, but taken together, these anomalies form a pattern. And that pattern does not look random, it looks deliberate, it looks engineered. And as October 29th, 2025 approaches, the tension in the scientific community is mounting, because that is the date of perihelion, the moment when 3I Atlas will make its closest approach to the Sun at a distance of 1.36 astronomical units, and for several weeks before and after perihelion, the object will be lost in the Sun's glare, too close to our star to observe from Earth. And during that time, humanity will be blind to what is happening. And this is where the fear creeps in. Because if this object is natural, then perihelion is simply the most active phase of its journey, when solar heating will drive intense outgassing and perhaps reveal more about its composition. But if this object is not natural, if it is a probe, if it is technology, if it has been traveling through the interstellar void for eons in a state of hibernation, then perihelion is the moment when it will drink deeply from the energy of a star for the first time in millennia or longer. And what will happen then? Will it simply continue on its hyperbolic trajectory and vanish back into the darkness? Or will it do something else? Will it alter its course? Will it activate? Will it transmit? Perhaps most unsettling of all, what if it already has? And we just have not noticed yet, because let us consider the timeline 3. Atlas was discovered on July 1st, 2025, but objects are not discovered. The instant they arrive, they are discovered when they become bright enough and close enough for our instruments to detect them, which means 3. Atlas was already well into the solar system, already on its sunward plunge before we even knew it existed. And if it is technology, then it has been observing us, studying our planet, our electromagnetic emissions, our radio and television broadcasts, our military radar, our satellite networks, for months before we saw it. And by the time we pointed our telescopes at it and started asking questions, it had already gathered whatever data it came for. And now, as it approaches perihelion, as it swings through the most intense radiation environment in the solar system, it will pass behind the sun and disappear from view. And when it re-emerges in early December, will it be the same object? Or will something have changed during those weeks of invisibility? This is the scenario that keeps some research. There's awake at night, the idea that perihelion is not just a passive, closest approach, but an active phase, a maneuver, a rendezvous, a planned event. Because if you were an advanced civilization and you wanted to send a probe to study a star system, you would design it to be inert during the long interstellar crossing to conserve energy and avoid detection. And then you would program it to activate when it reached a specific threshold of solar flux to recharge, to wake up to, begin its mission. And perihelion is exactly that threshold, the point of maximum energy input, and the fact that 3, Atlas's trajectory, brings it so close to multiple planets. Venus, Mars, Jupiter is another detail that feels less like coincidence and more like design. Because if your goal is to study a solar system, you do not just study the star, you study the planets, and you choose a trajectory that gives you close flybys of as many interesting targets as possible. And 3, Atlas's path does exactly that. And then there is the nickel. Dr. Michael Bush, a planetary astronomer, expressed a wish that the object would break apart so its internal composition could be studied. And this highlights a key problem. Right now, we are only seeing the surface. We are only analyzing the gases and dust that are venting from the outer layers. But what lies beneath? What is the core made of? And why is nickel, which is typically locked in metallic grains within, cometary ice being released in such quantities and in such a refined form, nickel tetracarbonyl? The compound, Avi Loeb, identified as the likely emission, is not just nickel. It is nickel bonded to carbon monoxide in a very specific molecular configuration. And this compound is highly volatile. It vaporizes easily, which is why it is used industrially for vapor deposition coating processes. You heat nickel metal in the presence of carbon monoxide, and you get nickel tetracarbonyl gas, which then decomposes on a surface to leave a pure nickel coating. And the fact that this exact compound, the one we use in aerospace manufacturing, is outgassing from an interstellar object is either the most bizarre coincidence in the history of astronomy, or it is evidence of materials, processing, of engineering, of construction. And if it is evidence of construction, then what are we looking at? A probe? A derelict spacecraft? An ark? A weapon? Because the other word that has been whispered in discussions about 3I Atlas is hostile. Avi Loeb himself, in earlier statements, suggested that the object could have potentially malevolent intent. And while this was widely dismissed as sensationalism, it is worth considering what hostile might mean in an interstellar context. It does not necessarily mean a battleship or an invasion force. It could mean a von Neumann probe, a self-replicating machine designed to explore the galaxy and exploit resources it encounters. It could mean a seed ship carrying biological or technological payloads intended to colonize or terraform. It could mean a surveillance network, a tripwire, a warning, a test. Or it could mean something we have no framework to understand because we are trying to interpret the actions of a civilization that might be millions of years more advanced than us using concepts and categories from our own brief technological adolescence. It would be like a Bronze Age human trying to understand a satellite. They might see it moving across the sky and conclude it as a bird or a god, but they would have no mental model for telecommunications, or orbital mechanics, or solar panels. And we might be in the same position looking at 3I Atlas and seeing a comet, because that is the closest thing in our experience, but missing the deeper reality, because we lack the context to recognize it. And this is why October 29th matters so much. Because perihelion is a test. If 3I Atlas is natural, then its behavior during and after perihelion should match predictions. It should outgas more intensely. As it heats up, it should perhaps fragment. If thermal stress cracks the nucleus, it should follow a trajectory determined solely by gravity and the rocket effect of outgassing. And then it should fade as it recedes from the sun, eventually disappear from our instruments as it heads back into interstellar space. But if 3 Atlas is not natural, then perihelion could be the moment when everything changes, because a probe emerging from hibernation would need to make decisions, assess its environment, determine whether its mission parameters are still valid, communicate with something, whether that is another probe, or a distant home base, or an AI network distributed across the galaxy. And those decisions and communications might manifest as changes in trajectory, changes in emission spectra, activation of systems that we would see as anomalous energy output, or even deliberate signals. And the fact that we will be unable to observe the object for several weeks during this critical period is both frustrating and terrifying, because by the time we see it again in December, it may have already done whatever it came here to do, and we will be left analyzing the aftermath, trying to reconstruct events from the data gaps and the changed parameters, and hoping that those changes are benign. Now, let us talk about the scientists, because the debate over 3I Atlas has exposed a deep rift in the astronomical community. On one side are the mainstream researchers who are deeply cautious about extraordinary claims. They point out correctly that the history of astronomy is full of anomalies that seemed inexplicable at first, but were later explained by natural processes. They remember the pulsar signals in 1967 that were briefly thought to be alien transmissions and turned out to be rotating neutron stars. They remember the wow signal and the many false alarms of SETI, and they are determined not to repeat the mistakes of premature speculation. So when they look at 3I Atlas, they see a comet. Yes, an unusual comet, perhaps even a record-breaking comet, but still fundamentally a natural object that can be understood through chemistry and physics, and they are frustrated by what they see as sensationalized coverage that jumps to the alien hypothesis without exhausting the natural explanations, and their frustration is understandable because science is supposed to be methodical, evidence-based, resistant to hype. But on the other side are researchers like Avi Loeb, who argue that the mainstream's cautio, N, has calcified into dogma, that the astronomical community has become so afraid of being wrong about aliens that it refuses to seriously consider the possibility even when the evidence warrants it. And Loeb's position is that we should be hypothesis agnostic. We should not privilege the natural explanation simply because it is more comfortable or more conventional. We should follow the data, and if the data points toward an artificial origin, then that hypothesis deserves to be on the table and to be tested rigorously rather than dismissed out of hand. And when you look at Loeb's career, this is not a fringe figure. This is the former chair of Harvard's astronomy department, the director of the Institute for Theory and Computation, a scientist with over 1,000 published papers and a track record of serious mainstream research. So when he says that 3I Atlas exhibits 8 major anomalies that warrant consideration of non-natural hypotheses, it is not idle speculation. It is a considered scientific judgment based on analysis of the best available data. And those 8 anomalies are worth listing explicitly. First, the Sunward Jet or anti-tail, which defies conventional cometary physics. Second, the nickel emissions without corresponding iron, which has never been observed in any natural object. Third, the specific nickel compound, nickel tetracarbonyl, which is used in industrial processes. Fourth, the orbital alignment within 5 degrees of the ecliptic, which has a probability of less than 0.2%. Fifth, the trajectory that brings it close to multiple planets, with a probability of 0.005% NT. Sixth, the extreme negative polarization and early inversion, which is unprecedented among known asteroids and comets. Seventh, the anomalously high mass, over 33 billion tons, which is far greater than expected for an object of its brightness. And eighth, the overall pattern of behavior, which does not match any known category of solar system object or any of the 2 previous interstellar visitors. And Loeb's argument is that while each anomaly, individually, might be explain the combination of all 8 anomalies pointing in the same direction toward an artificial origin creates a cumulative case that is stronger than the sum of its parts. And he asks, why is the burden of proof placed entirely on the artificial hypothesis? Why are we not equally skeptical of the natural hypothesis when it requires us to invoke multiple unprecedented processes and unlikely coincidences all occurring in the same object? And this is a fair question because science is supposed to favor the simplest explanation, the one that requires the fewest assumptions. And at a certain point, invoking a series of never-before-seen natural phenomena to explain away a pattern starts to look less simple than entertaining the possibility that the pattern is real and that it reflects design. But simplicity is subjective, and this is where personal and cultural biases enter the equation. Because for many scientists, the idea of Interstellar visitors of alien probes of contact is so disruptive to their worldview that it feels more complicated, even if logically it might be more parsimonious. And there is also the fear of professio, doubtful consequences, because astronomy has a long and embarrassing history of UFO cranks and alien claims, and no serious scientist wants to be lumped in with that crowd. So there is enormous social pressure within the field to not be the person who cries alien, to not be the one who gets it wrong and becomes a cautionary tale. And this pressure creates a systematic bias toward conservative interpretations, toward explaining things away even when the explanations require increasingly elaborate contortions. And this brings us to the present moment. October 19th, 2025, 10 days before perihelion, and the astronomical community is holding its breath because the next 2 weeks will be crucial. Every major telescope that can be brought to bear on 3I, Atlas, is being scheduled for observation time. The Hubble Space Telescope, the James Webb Space Telescope, the Keck telescopes in Hawaii, the Very Large Telescope in Chile, the ALMA radio array. All of them are racing to gather as much data as possible before the object disappears behind the sun. And the data that is coming in is not making things clearer. It is making them stranger, because the nickel emissions are not constant. They are variable. They fluctuate in intensity over timescales of hours and days. And this variability could be explained by rotation, as different parts of the surface face the sun and heat up at different rates. But the pattern of variation does not match the expected rotation period calculated from the light curve. And this mismatch suggests either that the object has a very complex irregular shape with hot spots and cold spots distributed in non-uniform ways, or that the emissions are being modulated by something other than simple rotation, by internal processes, by controlled venting, by deliberate signaling. And then there is the cyanide, because 3I Atlas is not just emitting nickel. It is also releasing large quantities of cyanide gas, specifically hydrogen cyanide. And this is actually normal for comets. Many comets emit HCN as ice's sublimate. But what is abnormal is the ratio, the amount of cyanide, relative to other expected cometary volatiles, like water and carbon dioxide, does not fit. The standard models in the cyanide production is rising steeply, much faster than predictions, based on the object's distance from the sun. And Avi Loeb has pointed out that cyanide is also a compound with industrial and chemical significance. It is used in electroplating, in the production of certain plastics, and in chemical synthesis. And while its presence on a comet is not by itself suspicious, the combination of cyanide and nickel in non-standard ratios adds another layer to the puzzle. Because if you were going to design a probe to survive the interstellar medium, you would need materials that are resistant to radiation, to cosmic rays, to micrometeorite impacts, and nickel alloys are excellent for that purpose. They are hard. They are durable. They do not corrode in vacuum. And if your probe used a closed-cycle chemical system for power, or propulsion, then cyanide compounds might be part of that system as a reactant or a byproduct. And what we might be seeing as outgassing could actually be venting of waste products or coolant or reaction mass from systems that are coming online as the probe warms up. But this is speculation, and the scientists who are tracking 3I Atlas are careful to label it as such because the truth is, we do not know and we will not know until we get more data. And possibly not even then, because there are fundamental limits to what we can learn from telescopic observation alone. We can measure light, we can measure spectra, we can track position and velocity, but we cannot see inside the object. We cannot determine its internal structure. We cannot distinguish between a solid nucleus and a hollow shell with equipment inside. And this is why several groups have proposed sending a spacecraft to intercept 3I Atlas to fly close, enough to image the surface at high resolution, to sample the outgassing directly, to use ground-penetrating radar to map the interior. And there are two missions that are being fast-tracked for possible launch. The European Space Agency has a concept called the Comet Interceptor, which was originally designed to visit a long-period comet, but could be retargeted to 3I Atlas, and the Japanese Space Agency JAXA has experience with sample return missions to asteroids, and is evaluating whether a rapid response mission could be mounted. And the challenge is timing, because 3 Atlas is moving fast. It is on a hyperbolic trajectory, and once it swings past the sun, it will be accelerating outward. And there is only a narrow window during which a spacecraft launched from Earth could catch up to it. And that window is closing, and the cost would be enormous. And there is no guarantee of success. SpaceX Raft take years to design and build and launch, and 3I Atlas will be gone from the inner solar system by mid-2026. So any mission would have to use existing hardware and cut every possible corner and accept a high risk of the failure. But the potential payoff is incalculable, because if there is even a 1% chance that 3I Atlas is of artificial origin, then studying it up close is the most important thing humanity could do, because it would answer the oldest question: are we alone? And it would give us our first glimpse of technology from beyond Earth, and it would tell us that intelligence is not unique to our planet, that it arises elsewhere, that the universe is full of minds, civilizations, and that our future is not one of cosmic loneliness, but of potential contact, trade, communication, conflict, all the possibilities that come with knowing there are others. But it would also raise terrifying questions, because if 3 Atlas is a probe, then who sent it, and when, and why? And are they still out there? And do they know we are here? And what do they want? And these are questions that humanity is not ready to answer, because we have no protocols for contact, no unified decision-making structure, no way to respond as a species rather than as a collection of competing nations and corporations and ideologies. And the history of contact on Earth between cultures with different levels of technology is not encouraging. It is a history of conquest and exploitation and disease and cultural destruction. And while interstellar distances might protect us from some of those dangers, they do not protect us from information hazards from the knowledge that we are not alone, and that we are almost certainly not the most advanced, from the psychological and social upheaval that would come from confirmed contact. And this is why some scientists, some government officials are arguing for caution, for secrecy, for a slow, careful disclosure of information rather than a sudden revelation. And there are rumors, unconfirmed but persistent, that classified observations of 3I Atlas have been made by military satellites and ground-based sensors, and that the data from those observations has not been shared with the civilian scientific community. And if true, this would represent a troubling precedent, because the question of whether we are alone is not a military question. It is a human question. And the answer belongs to all of us. Not to a classified few, but national security concerns are real, because if 3I Atlas is technology, then it represents a level of capability far beyond anything Earth possesses. The ability to cross interstellar space, the ability to survive for millions of years in the void, the ability to navigate and maneuver, and possibly communicate across light years, and any civilization with that level of technology would also have capabilities in energy manipulation, in propulsion, in material science, that would render our most advanced weapons primitive by comparison. And so the military and intelligence establishments of the major powers are watching 3I Atlas very carefully, not because they think they can fight it, but because they want to know what it does and where it goes, and whether it poses any immediate threat. And also because they want to know if any other nation has better information. If China, or Russia, or the United States has secret data that could provide an advantage in understanding or responding to this phenomenon. And this is how first contact could become geopoliticized. How a question of cosmic significance could be reduced to another arena for great power competition. And this would be tragic, but it would also be very human, because we are a young species. We are tribal, we are competitive, we are still learning how to cooperate on a global scale, and we are probably not ready for contact, but contact, if that is what this is, does not wait for us to be ready. It happens on its own schedule, and that schedule might be October 29th, 2025, might be the day when 3I Atlas reaches perihelion and either confirms itself as a comet or reveals itself as something else. And this is why the next 10 days are so important, because they are the last chance for unobstructed observation. The last window before the sun's glare makes it impossible to track the object. And scientists are working around the clock, analyzing every photon of light, every spectral line, every data point, trying to squeeze out more information, trying to resolve the ambiguities. And the preliminary results are not reassuring, because the more data that comes in, the less the object looks like a comet, and the more it looks like an anomaly. And there are now multiple independent research groups who have run the numbers and come to the same conclusion that the probability of all of 3I Atlas's observed characteri sticks occurring naturally in a single object is vanishingly small, less than 1 in a million, less than 1 in a billion, depending on which anomalies you include and how you calculate the probabilities. And at a certain point, a probability that low stops being a probability and starts being an impossibility. And when you encounter an impossibility in science, you have two choices. Either your understanding of what is possible is incomplete, and you need to revise your models, or the thing you are observing is not what you think it is. And for 3I Atlas, both of those choices lead to the same place, to the conclusion that this is not a typical comet, that it is something new, something we have never seen before. And whether that something is a natural phenomenon driven by exotic chemistry and physics, or an artificial phenomenon driven by technology and intelligence, is the question that will define the next chapter of human history. And the answer is coming soon, because perihelion is 10 days away, and the clock is ticking, and the world is watching, And the scientists are arguing, and the data is accumulating. And somewhere in the darkness, beyond Mars, an object the size of Manhattan, hurtling toward the sun, trailing a plume of industrial nickel and cyanide and pointing a jet of material sunward, in defiance of every rule we know, and in the control rooms and observatories and university offices where the experts gather, there is a feeling that is hard to articulate, a mixture of excitement and dread, because they know they are living through a moment that will be remembered. They know that future historians will look back at October 2025 and mark it as a turning point, and they know that the next piece of data, the next observation, the next anomaly, could be the one that changes everything. And so they watch and they wait, and they hope that when the answer comes, they will be ready to understand it and to explain it to a world that is not ready to hear it. Because how do you tell 8 billion people that the universe just sent us a visitor, and that visitor is not playing by the rules, and that we have no idea what it wants or what it will do next? And how do you maintain calm and order and rational discourse in the face of that revelation? And how do you prevent panic or exploitation or collapse of the fragile consensus that holds civilization together? And these are the questions that keep the experts awake at night as October 29th approaches, as the observing window narrows, as the data gets stranger and stranger. Somewhere in a basement office at Harvard University, Avi Loeb is writing another paper, compiling another list of anomalies, adding more evidence to the case he has been building since July. And he knows that he is risking his reputation, that his colleagues think he has gone too far, that the mainstream will not forgive him if he is wrong. But he also knows that if he is right, then the risk is worth it, because the truth matters. And the question of whether we are alone matters. And the possibility that an interstellar probe is passing through our solar system right now matters more than careers or reputations or the comfort of conventional thinking. And in the Canary Islands and Hawaii and Chile telescope operators are queuing up observation sequences, checking calibrations, preparing for long nights of data collection, because the next 10 days are critical. And in conference rooms at NASA and ESA and space agencies around the world, engineers are pulling up mission plans, dusting off old proposals, calculating delta-V budgets and launch windows, trying to figure out if it is possible, if there is any way to get a spacecraft to 3I Atlas before it is too late. And in newsrooms and television studios, journalists are writing scripts, preparing segments, trying to explain to the public what is happening and why it matters, without causing panic, without overselling the alien angle, but also without underselling the genuine strangeness of this object. And in living rooms and offices and schools, people are starting to pay attention because the news is leaking out, because the headlines are getting harder to ignore. Manhattan-sized object, emitting industrial alloy interstellar visitor, defies physics. Harvard scientist says it could be alien technology. And the comment sections are filling up with speculation, with jokes, with fear, with hope, with anger, with disbelief. And this is how it begins, not with a dramatic landing or a clear signal, but with ambiguity, with data that does not quite fit, with questions that do not have easy answers, with a slow creeping realization that something is different, that the universe is not quite what we thought, and that we might be on the verge of a discovery that will rewrite everything, and whether that discovery is a new type of tea or a message from the stars. The fact that we are asking the question, the fact that we are forced to take the possibility seriously, is itself a threshold, because it means we have reached a point in our technological development where we can detect interstellar visitors, where we can analyze their composition, where we can track their trajectories and ask whether they are natural or designed. And that capability brings responsibility. Because if we can ask the question, then we have to be prepared for the answer. And if the answer is that we are not alone, then we have to decide what to do with that knowledge and how to move forward and who speaks for Earth and what do we say. And these are not abstract, philosophical questions anymore. They are practical, urgent, immediate questions, because the object is here now, and perihelion is in 10 days. And after that, we will know more or we will know less, but we will not be able to go back to the comfortable certainty of a universe where interstellar visitors are just comets, where anomalies are just measurement errors, where the question of alien life is something for science fiction, not science. And perhaps that is the real significance of 3I Atlas. Not whether it is a probe or a comet, but that it forces us to confront the question, that it makes the abstract concrete, that it takes the possibility of extraterrestrial intelligence out of the realm of speculation and into the realm of hypothesis testing and data analysis. And that shift is irreversible, because once you start looking, once you start taking the possibility seriously, you cannot unsee the HE patterns. You cannot unask the questions. And even if 3I Atlas turns out to be natural, even if every anomaly is explained, even if it is just a very weird comet, the fact that we considered the alternative means that the next time another object arrives, we will consider it again, and eventually one of those objects will be the real thing. And when that happens, we will need to have figured out how to respond. And 3I Atlas is our dress rehearsal, our practice run, our chance to work through the protocols and the debates and the fears before the stakes are even higher. And in that sense, regardless of what it is already serving a purpose, because it is preparing us. It is forcing us to think about questions we have been avoiding, and to develop frameworks for understanding what contact might look like, and how we would know, and what we would do. And those frameworks will be essential because the universe is vast and old and full of stars. And the idea that Earth is the only place where chemistry became biology, and biology became intelligence, and intelligence became technology, is statistically implausible. And if intelligence is common, then so are probes, so are signals. So are artifacts left behind by civilizations that came before, and the fact that we have not seen them yet might just mean we have not been looking hard enough or in the right ways. And 3, Atlas is teaching us how to look. It is showing us what interstellar objects can look like, how they move, what signatures they leave. And even if this one is natural, the next one might not be, and we will be ready, or at least more ready, than we are now. And perhaps that is the most important lesson, that the search for extraterrestrial intelligence is not just about listening for radio signals or analyzing distant exoplanet atmospheres. It is also about paying attention to what enters our solar system, about studying every asteroid and comet and piece of interstellar debris with the rigor and seriousness that befits the possibility that one of them might be more than it seems. And 3, I Atlas. Whether it is a comet or a probe has earned that scrutiny because it is strange enough that we cannot ignore it, anomalous enough that we cannot dismiss it, and important enough that we cannot afford to get it wrong. And so, the scientific community, despite its internal disagreements, despite the career risks and the fear of ridicule, is doing what it is supposed to do. It is gathering data, it is testing hypotheses, it is following the evidence wherever it leads. And in 10 days, when 3I Atlas reaches perihelion and disappears behind the sun, we will have our answer, or at least the beginning of one, and the world will be watching. And history will judge whether we rose to the occasion, whether we faced the question with courage and honesty, and whether we were ready for the truth, whatever that truth turns out to be. And as the days count down, the scientific observations are becoming more intense and more sophisticated because researchers are not just looking at 3I Atlas with optical telescopes. Anymore, they are hitting it with every tool in the arsenal. Radio telescopes are scanning for any signals, any transmissions, any periodic pulses that might indicate artificial activity. And so far, they have found nothing, but the absence of a signal is not proof of anything, because an advanced probe might operate on frequencies we are not monitoring or use communication protocols. We would not recognize or simply be in listening mode rather than transmitting mode, and the Breakthrough Listen project, which is the most comprehensive search for extraterrestrial intelligence ever mounted, has dedicated a significant portion of its observing time to 3I Atlas. And they are looking not just for deliberate signals, but for any electromagnetic emissions that might leak from the object, any radar, any telemetry, any power systems that might radiate in ways that natural objects do not. And again, they have found nothing conclusive, but they have found hints, strange, transient bursts of radio emission that appear and disappear too quickly to characterize that might be instrumental artifacts or cosmic ray hits, or interference from Earth-based transmitters, or they might be something else. And the frustration for the radio astronomers is that 3I Atlas is still relatively far away and relatively faint in the radio spectrum, and by the time it gets close enough for really detailed observations, it will be too close to the sun. And the sun is the loudest radio source in the solar system, and trying to detect faint signals from an object near the sun is like trying to hear a whisper next to a jet engine. And so there is a very narrow window, maybe 3 or 4 more days, when the geometry is favorable, when the object is close enough to study, but far enough from the sun that the background noise does not overwhelm everything. And during that window, the radio telescopes will be listening constantly, recording every photon, analyzing every fluctuation, looking for patterns. And the same is true for infrared observations, because if 3I Atlas has any internal heat sources, if it is warmer than it should be based on solar heating alone, then that would show up in the infrared. And the James Webb Space Telescope has been tasked with making those observations, and the preliminary data is intriguing because there are regions on the object that do appear to be slightly warmer than expected. Not dramatically so, but enough to be noticeable, and this could be explained by subsurface ice that is insulating some areas and causing heat to build up, or it could be explained by dark patches on the surface that absorb more sunlight, or it could be explained by internal heat generation, by decay of radioactive isotopes, or by chemical reactions, or by machinery. And the Webb data is still being analyzed, and the scientists are being very careful not to overinterpret. But the thermal map of 3, Atlas, does not look like the thermal map of a typical comet. It has hot spots and cold spots in places that do not make sense based on the rotation and the angle to the sun. And this is yet another anomaly to add to the growing list. And then there is the spectroscopic data, because every atom and molecule emits and absorbs light at very specific wavelengths. And by spreading the light from 3 Atlas into a spectrum, scientists can identify what chemicals are present and in what quantities. And ATLAC D, the spectrum of 3 Atlas, is bizarre. It shows the expected cometary volatiles: water, vapor, carbon dioxide, carbon monoxide, but in ratios that are off. And it shows the nickel emission lines, which are strong and unmistakable, and it shows cyanide. And it also shows traces of other metals: iron, chromium, aluminum, in very small amounts but detectable. And the presence of multiple metals is not by itself strange, because rocky material is always mixed with ice in comets, but the relative abundances are strange. The ratios do not match any known class of solar system object, and they do not match the compositions measured for interstellar dust grains. And they do not match theoretical models of what primordial, the material from other star systems, should look like. And Avi Loeb has pointed out that the metal ratios are actually somewhat similar to stainless steel, which is an alloy of iron, chromium, and nickel, designed for strength and corrosion resistance. And he is careful to note that this does not prove anything, because nature can produce metal alloys through differentiation and geochemical processes. But it is suggestive, especially when combined with all the other anomalies, and the fact that the metals are being detected in the gas phase rather than as solid grains means they are vaporizing, which requires high temperatures. And the question is, where are those high temperatures coming from? Because the surface of 3 I Atlas, even at perihelion, should not be hot enough to vaporize metals. And this suggests either that there are localized areas where temperatures are much higher than average, perhaps due to concentrated sunlight reflecting off ice facets, or perhaps due to exothermic chemical reactions on the surface, or perhaps due to something else. And the something else is what keeps coming up in the discussions, because every natural explanation requires invoking a process that has never been observed before, a phenomenon that is theoretically possible, but has never actually been seen. And at a certain point, you have to ask whether it is more reasonable to stack up a dozen unprecedented natural phenomena, or to consider one unprecedented artificial phenomenon. And this is the core of the debate. And it is not a debate that will be resolved by rhetoric or by authority. It will be resolved by data, and the data is coming in fast now, because every observatory that can see 3I Atlas is observing it, and the data is being shared in real time through online platforms and preprint servers, because the scientists involved know that this is too important for the usual slow peer review process that the world needs to know what is happening as it happens. And this open science approach is unprecedented for such a high-profile discovery. But it is also necessary because the stakes are so high, and because no single team or institution has all the answers, and because the problem is so complex that it requires collaboration on a global scale. And so we are seeing a kind of real-time collective intelligence at work, with researchers from dozens of countries contributing observations and analyses and interpretations, and building together a picture of what 3I Atlas is and what it might mean. And that picked, your is still incomplete and contradictory and frustrating, but it is also exhilarating because this is science at its best. This is the process of discovery unfolding in public with all its uncertainties and disagreements and false starts and breakthroughs. And the public is watching and learning and participating in a way that has never happened before, because social media and online forums are full of amateur astronomers and citizen scientists who are analyzing the publicly available data and asking questions and proposing hypotheses. And some of those hypotheses are wild and unsupported, but some of them are insightful and valuable. And this democratization of the discovery process is changing the relationship between science and society, because people are not just passively receiving information from experts, they are engaging with the data themselves and forming their own opinions. And this is both empowering and dangerous, because not everyone has the background to interpret the data correctly, and misinformation spreads fast, and conspiracy theories are already proliferating. And some of them are bizarre claims that 3 Atlas is a weapon sent by a hostile alien. Civilization claims that it is going to crash into Earth, or release a plague, or emit radiation that will sterilize the planet. And these claims are baseless and irresponsible, but they are also understandable because fear is a natural response to the unknown. And the unknown is exactly what we are dealing with. And so scientists and communicators are working hard to provide accurate information, to debunk the false claims, to reassure the public that there is no evidence of any immediate threat, but also to be honest about the uncertainties, to admit that we do not have all the answers, and that some of the possibilities are genuinely strange. And this balance between reassurance and honesty is difficult, because if you emphasize the strangeness, you risk causing panic. But if you emphasize the reassurance, you risk being accused of a cover-up if it turns out that the object is more significant than you admitted. And this is the tightrope that NASA and ESA and other official agencies are walking right now, because they have a responsibility to inform the public, but also a responsibility not to cause unnecessary alarm. And the statements they have released so far have been carefully worded, emphasizing that 3 Atlas is being studied, emphasizing that it poses no danger to Earth, emphasizing that more data is needed before any conclusions can be drawn, but also acknowledging that the object has unusual properties that are not fully understood. And these statements are technically accurate, but they are also somewhat evasive, because they do not address the central question that everyone is asking, which is, could this be alien technology? And the reason they do not address that question is because there is no scientific consensus on the answer, because the data is ambiguous, because the implications are so profound that no one wants to be the official voice saying, yes, this might be a probe, until they are absolutely certain. And the threshold for absolute certainty in a claim, this extraordinary, is very high. It requires not just 1 or 2 anomalies, but overwhelming evidence. It requires ruling out every possible natural explanation. It requires multiple independent lines of evidence, all pointing in the same direction. And we are not there yet. We might never get there, because the object is going to disappear behind the sun in a few days. And by the time it re-emerges, it might be too far away and too faint for detailed study. And so there is a very real possibility that 3I Atlas will remain a mystery, that it will join Oumuamua and the WOW signal and the fast radio bursts and all the other cosmic anomalies that are suggestive but not conclusive. And this would be deeply frustrating for the scientists who have invested so much time and effort into studying it, but it would also be a learning experience because it would show us the limits of what we can determine from telescopic observations alone, and it would strengthen the case for interception missions, for sending spacecraft to meet these objects up close, where we can image them and sample them and probe them and answer the questions that telescopes cannot. And there is a growing movement within the space community to establish a fourth-in, rapid response capability. For exactly this purpose, a spacecraft, or a fleet of spacecraft, kept on standby, ready to launch on short notice whenever an interstellar object is detected. And the technology to do this exists. It is not science fiction. It is engineering and logistics and funding, and the cost would be significant but not prohibitive. A few $100 million, which is a rounding error in the budgets of major space agencies, and the scientific return would be immense because every interstellar object is a sample of another star system, a messenger carrying information about the chemistry and physics and possibly the biology of worlds we will never visit. And if even one of those objects turns out to be artificial, then the return on investment is incalculable. And so, the case for a standing interstellar object interceptor mission is strong. And it is being made loudly by researchers like Avi Loeb, and by planetary scientists, and by astrobiologists. And the question is whether the political will exists to fund such a mission, whether governments and space agencies are willing to commit resources to what might seem like a speculative venture. And the answer to that question may depend on what happens with 3I Atlas. Because if this object continues to defy explanation, if the anomalies pile up, if the public interest remains high, then it might create the political momentum needed to approve a mission. And in that sense, 3 Atlas is not just a scientific phenomenon, it is also a political and cultural phenomenon. It is a catalyst for conversations about our place in the universe, about the place in search for life, about the risks and opportunities of contact. And those conversations are happening now in universities and government offices and dinner tables and online forums. And they are shaping the way we think about the future, the way we prioritize our resources and our attention. And this is perhaps the most important legacy of 3I Atlas, that it is forcing us to take seriously the possibility that we are not alone, and to think about what that means and how we should prepare and whether we are ready. And the answer to that last question is almost certainly no, we are not ready, but we are more ready than we were a year ago, and we will be more ready a year from now. And readiness is not a binary state. It is a process. And 3I Atlas is part of that process. And now, let us return to the science. Because while the debates rage, and the public speculates, and the politicians consider, researchers are still doing the unglamorous work of data collection and analysis, and there are some new developments that have emerged in just the last 48 hours that add yet more complexity to the picture. First, there is the rotation, period, or rather, the lack of one. Because most asteroids and comets have a measurable rotation. They spin on an axis, and that spin causes their brightness to vary in a periodic way, as different parts of the surface catch the light. But 3, Atlas does not show a clear periodic variation. Its brightness fluctuates, but not in a regular pattern. And this could mean that the object has a very slow rotation period measured in days or weeks rather than hours. Or it could mean that the object is not rotating at all, which would be extremely unusual, because every object in space experiences torques from gravity and from outgassing, and those torques induce rotation. And the only way an object could maintain zero rotation if those torques are being actively counteracted, if there is some kind of stabilization mechanism at work. And for a natural object, that mechanism would have to be internal mass redistribution or specific outgassing patterns. But for an artificial object, it could be as simple as thrusters or reaction wheels, and the fact that we cannot determine the rotation period is frustrating, because rotation is one of the most basic properties of an object, and it tells you a lot about its shape and structure and history. And without that information, we are missing a crucial piece of the puzzle. And second, there is the composition of the dust, because while most of the attention has been on the gases, the cyanide and the nickel, there is also dust being released from the object. And that dust can be analyzed by looking at how it scatters light. And the preliminary results suggest that the dust grains are unusually uniform in size, with a very narrow size distribution. And this is strange, because natural cometary dust usually has a wide range of grain sizes, from submicron particles up to millimeter-sized chunks, reflecting the chaotic off-fragmentation processes that create the dust. But 3I Atlas's dust is more monodisperse, more like an aerosol or a powder that has been sieved or processed. And this could be a natural result of some kind of sorting mechanism, perhaps. Electrostatic forces in the coma, or perhaps differential sublimation rates. But it is also consistent with manufactured particulates with dust that has been intentionally produced to a specific size for some purpose, such as thermal control or propulsion or shielding. And third, there is the trajectory refinement, because as more observations come in, the orbital calculations are becoming more precise, and the refined orbit shows something interesting, which is that 3I Atlas did not just happen to pass through the inner solar system, it passed very close to Mars on October 9th, 2025, at a distance of just 12 astronomical units, or about 18 million kilometers. And this is not a collision course, and it is not unusually close by cosmic standards, but it is close enough that if the object had any instruments, if it had cameras or spectrometers, then it would have gotten an excellent view of Mars and its moons, and possibly even detected the signatures of the human spacecraft and rovers currently operating on the surface. And the timing is interesting, because Mars is currently at a favorable position in its orbit for observation. And if you were designing a flyby trajectory to study the solar system, Mars would be one of your high priority targets, because it is the most Earth-like planet, because it has evidence of past water, because it is a candidate for life. And so the close approach to Mars could be coincidence, or it could be design. And we will never know for certain unless we find more direct evidence. But it is one more item on the list of things that make 3I Atlas look less like a random interstellar wanderer and more like something following a plan. And fourth, there is the mystery of the anti-tail's structure, because high-resolution images from Hubble are now showing that the Sunward Jet is not uniform. It has structure. There are filaments and knots and regions of higher and lower density, and this structure is evolving over time, changing over the course of hours, days. And this kind of dynamic fine structure has never been seen in a cometary jet before, and it suggests that the emission is not a simple steady outflow, but something more complex, something turbulent, or pulsed, or modulate, D. And fluid dynamic simulations are being run to try to reproduce the observed structure, and so far none of the models are working. None of them can produce the right combination of filaments and knots with the observed timescales unless you invoke very specific assumptions about the gas composition and temperature and velocity, and those assumptions are themselves not well justified by other observations. And so, the anti-tail remains one of the most perplexing features of 3I Atlas, and one of the strongest pieces of evidence that this object is not behaving like a normal comet. And now, with perihelion just days away, the anticipation is reaching a peak because perihelion is when comets are most active, when solar heating is at maximum, when outgassing rates spike, when tails grow longer and brighter, and when objects sometimes fragment under the thermal stress. And if 3 Atlas fragments, if it breaks apart, then we will finally get to see what is inside. And that would be a scientifically valuable event, even if it is also a tragic one, because it would mean the end of the object. But it would also reveal its interior composition, its structure, whether it is a solid nucleus or rubble pile or something else entirely. And there are some researchers who are actually hoping for fragmentation because it would resolve so many uncertainties. But there are others who are hoping it survives, because if it is a probe, then its survival would tell us something about the engineering, the materials, the design, philosophy of whoever built it, and the fact that scientists are rooting for different outcomes, a measure of how polarized the community has become, because your preferred outcome depends on your hypothesis, and your hypothesis depends on your prior beliefs about what is more likely natural or artificial. And these prior beliefs are not always based on evidence. They are based on intuition, on philosophy, on temperament. And this is where science bumps up against human psychology, because we like to think of science as objective. But scientists are human, and humans have biases and preferences, and those biases affect how we interpret ambiguous data. And 3I Atlas is nothing if not ambiguous. It is a Rorschach test in which everyone sees what they are predisposed to see. And the only way to break through that subjectivity is with data that is so clear, so unambiguous, that it forces everyone to agree. And we do not have that data yet, and we might not get it, but we are hoping. And as the hours count down as 3I Atlas races toward its appointment with the sun, as the observatories track its every move, there is a feeling in the air that something is about to happen, that we are on the verge of a revelation or a disappointment. But either way, a resolution and the world is watching and waiting and hoping that when the moment comes, we will be ready for whatever truth emerges from the data and the debates and the theories. And in the end, that is what this is all about. Not just 3I Atlas itself, but what it represents: possibility that the universe is more than we imagined. The possibility that intelligence and technology and curiosity are not unique to Earth. The possibility that out there in the vast darkness between the stars, there are others who have asked the same questions we are asking and who have sent their own emissaries out into the void to explore and to learn and perhaps to make contact. And if 3I Atlas is one of those emissaries, then this is the beginning of a new chapter in human history. And if it is not, then it is still a reminder that we should keep looking, keep asking, keep searching, because the answer is out there somewhere, and one day we will find it. And now we arrive at the most profound question of all, which is what happens next. Because regardless of whether 3I Atlas is a comet or a probe, the fact that we are asking this question, the fact that we have the technology to detect and study interstellar objects, means that this will not be the last time we face this uncertainty. And the next interstellar visitor might arrive next year or next decade, and it might be even stranger than 3 Atlas, or it might be unambiguous. And when that happens, we need to have systems in place. We need protocols and frameworks and international agreements about how to study such objects, how to share data, how to make decisions, and how to communicate with the public. And right now, those systems do not exist. There is no international body with authority over interstellar objects. There is no agreed-upon process for determining whether something is natural or artificial. There is no plan for what to do. If we confirm contact, and this lack of preparedness is understandable, because until recently, interstellar objects were purely theoretical. We knew they had to exist, but we had never seen N1. And then in 2017, Oumuamua appeared, and it was strange with its elongated shape and its non-gravitational acceleration and its lack of cometary outgassing, and the debate over Oumuamua, natural or artificial, was fierce and divisive and ultimately unresolved. And then in 2019 came 2I Borisov, which was much more comet-like, much less controversial. And it seemed to settle the question. It seemed to say that interstellar objects are just comets from other star systems. Nothing special, nothing extraordinary. And then came 3I Atlas, and all the certainty evaporated, because this object is stranger than Oumuamua, stranger than anything we have seen, and it is forcing the scientific community and the world to confront the possibility that interstellar space is not empty, that it is full of objects, some natural and some perhaps not, and that as our detection capabilities improve, we are going to see more and more of these visitors, and we need to be ready. And being ready means investing in better telescopes, better spectroscopy, better models, and also better spacecraft, because telescopic observation has limits, and those limits are becoming painfully obvious with 3I Atlas. Because we can see the object, we can measure its light, we can analyze its spectrum, but we cannot touch it, we cannot sample it, we cannot look inside, And without that direct contact, there will always be ambiguity, there will always be room for doubt. And so the case for interception missions is not just scientific, it is epistemological. It is about what we can know and how we can know it. And the technology exists today to build a spacecraft that could rendezvous with an interstellar object. We have ion drives, we have solar sails, we have nuclear propulsion concepts that could provide the delta V needed to catch up to a hyperbolic trajectory. And we have miniaturized instruments, cameras, spectrometers, magnetometers, radar, that could fit on a small probe and provide detailed, up-close data, and the cost of such a mission would be comparable to a flagship planetary mission. A few $billion, which is expensive but not impossible, and the scientific and cultural value would be enormous because it would give us ground truth. It would give us unambiguous data about what these objects are and where they come from and what they are made of, and whether any of them show signs of design. And this is why several space agencies and private organizations are now seriously considering rapid response interstellar object missions. And there are proposals on the table and feasibility studies underway. And if 3I Atlas generates enough public interest and political will, then one of those proposals might get funded, and we might have a spacecraft ready to launch the next time an interstellar visitor arrives. And that would be a turning point, because it would mean that we are no longer passive observers, that we are actively engaging with the interstellar environment, that we are reaching out beyond our solar system, not with signals, messages, but with physical presence, with hardware. And this is the first step toward becoming an interstellar civilization. And it is a step that humanity is on the verge of taking, whether we realize it or not. And 3I Atlas is the catalyst, and beyond the spacecraft and the telescopes, there is the question of how we interpret what we find. Because even with perfect data, even with a probe sitting on the surface of 3I Atlas, taking samples and transmitting high-resolution images, there would still be debate, because the question of what counts as evidence of design is not straightforward. And this is something that the SETI community has grappled with for decades. Because if you receive a radio signal from space, how do you know it is artificial? How do you distinguish between a deliberate transmission and a natural astrophysical process? And the answer is that you look for patterns, for information, content, for modulation, for structure that is too complex or too specific to arise from natural processes. And the same principle applies to physical objects. You look for materials that do not occur naturally, for structures that serve functions, for asymmetries that indicate purpose. And for 3I Atlas, we have some of those signatures: the nickel alloy, the sunward jet, the uniform dust grains, the unusual orbit. But we do not have smoking gun evidence. We do not have markings or inscriptions or obvious machinery. And so the debate continues, and it will continue even after perihelion, even after the object re-emerges from behind the sun, because the bar for accepting an extraordinary claim is very high, and that is as it should be, because the consequences of being wrong are significant. If we claim that an object is artificial and it turns out to be natural, then we damage the credibility of the scientific.com, unity and fuel conspiracy theories and undermine public trust, But if we claim that an object is natural and it turns out to be artificial, then we miss the most important discovery in human history. And there is no easy way to balance those risks. And so scientists err on the side of caution. And this is why Avi Loeb's willingness to publicly entertain the artificial hypothesis is both controversial and valuable, because someone needs to be willing to take that risk. Someone needs to be willing to say what the data suggests, even if it is uncomfortable, even if it invites ridicule. And Loeb has paid a price for his outspokenness. He has been criticized by colleagues. He has been accused of attention-seeking. He has been dismissed as a fringe figure, but he has also opened up space for the conversation. He has made it acceptable to ask the question. And that is important because science progresses by asking questions, by challenging assumptions, by refusing to accept easy answers when the data demands more. And 3, Atlas demands more. It demands that we look harder, that we think deeper, that we consider possibilities we would prefer to ignore, and whether it is ultimately explained as a comet or as a probe. The process of engaging with that question is making us better scientists and better thinkers. And now let us consider the societal implications, because the debate over 3 Atlas is not happening in a vacuum. It is happening in a world that is already grappling with rapid technological change, with AI and biotechnology and climate change and geopolitical instability, and the possibility of contact W with extraterrestrial intelligence adds another layer of uncertainty, another source of disruption. Because if we confirm that 3 Atlas is artificial, then every assumption about humanity's uniqueness, about our place in the cosmos, has to be revised. And that revision will ripple through religion, through philosophy, through politics, through economics, because it will tell us that intelligence is common, that technology is common, that we are not special. And for some people, that will be a liberating revelation, a sign that we are part of something larger. But for others, it will be deeply threatening, a challenge to belief systems and identities that are built on the idea of human exceptionalism and the social and psychological effects of confirmed contact are hard to predict because we have no historical precedent. There have been speculative studies and scenarios and think tank reports, but they are all based on guesswork because we do not know how people will react, and we do not know how institutions will respond, and we do not know whether the net effect will be unifying or divisive. And the answer probably depends on the details, on what the contact looks like, on whether it is clearly benign or ambiguous or threatening. And 3, Atlas, even if it is a probe, is ambiguous because it is not communicating, it is not landing, it is not making demands, it is just passing through, observing, perhaps recording, but not engaging. And that ambiguity is in some ways more unsettling than a clear signal, because it leaves us with questions and no way to get answers. And humans do not like unanswered questions. We like closure. We like resolution. And 3 Atlas is not giving us that. And as we move into the final days before perihelion, as the object approaches the sun and the observing conditions worsen, there is a sense of time running out, a sense that we are about to lose our chance. And this sense of urgency is driving some scientists to take risks, to push the boundaries of what their instruments can do, to squeeze out every last bit of data. And there have been some remarkable observations in the last 24 hours, including a spectroscopic campaign that caught 3I Atlas at a moment when the nickel emission spiked dramatically for about 20 minutes and then dropped back to baseline. And this transient spike is hard to explain because there is no obvious trigger, no change in solar illumination, no rotation that would bring a new surface area into view. And yet the emission rate increased by a factor of 5 and then returned to normal. And this kind of variability is suggestive of episodic venting, of localized events, of something happening beneath the surface or within the structure that releases gas in bursts rather than steady flows. And again, this could be natural ice. Sublimation can be episodic when pockets of pressure build up and then rupture, but it could also be something else. Venting of tanks, adjustment of attitude, short burns of a propulsion system, and the fact that we cannot distinguish between these possibilities is the source of endless frustration and also endless fascination, because every new observation adds another piece to the puzzle. But the puzzle is not getting clearer. It is getting more complex. And there are now researchers who are arguing that 3I Atlas is not a single object, but a cluster, a swarm of smaller objects flying in formation. And this would explain some of the anomalies, the variable emissions, the complex structure of the antitail, the unusual thermal signature, because if you have multiple objects, each with its own outgassing pattern, then the combined signature would be more complex than a single nucleus. And there is some precedent for this, because comets do sometimes fragment into multiple pieces, and those pieces can remain gravitationally bound for a while before drifting apart. And so the swarm hypothesis is plausible, but it is also untestable with current data, because the resolution of even the best telescopes is not good enough to separate individual components if they are closely spaced. And so this is another question that will remain unanswered unless we get closer, unless we send a mission. And the call for such a mission is growing louder and more urgent, and there are now serious discussions at NASA and ESA about whether it is feasible to repurpose an existing spacecraft or to fast-track a new mission, and the technical challenges are enormous, because 3I Atlas is moving at more than 60 kilometers per second relative to the Sun, and matching that velocity requires a huge amount of energy, more than any currently operational spacecraft has. And so you would need either a very powerful rocket or a gravity assist trajectory that uses the Sun or planets to accelerate. But those trajectories take time to design and execute. And time is the one nung we do not have, because 3I Atlas will be leaving the inner solar system by mid-2026, and after that, it will be too far away for any reasonable mission to catch. And so the window is closing, and the decision of whether to go has to be made soon. And it is a decision that involves not just technical and financial considerations, but also political ones, because a mission to intercept 3I Atlas would be a statement. It would be a declaration that humanity takes the possibility of extraterrestrial intelligence seriously, that we are willing to invest resources in exploring that possibility, and that is a statement that some governments are reluctant to make because it opens up questions about what comes next, about what we do if we find something about Who has authority and who decides? And these are not easy questions, and they do not have clear answers. And so the default is often to do nothing, to wait for more information, to defer, and the decision. And this is understandable, but it is also tragic because opportunities like this do not come often. And if we let 3I Atlas slip away, we might be waiting decades for another chance. And in the meantime, the questions will remain unanswered. The debates will continue, the uncertainty will persist, and we will be left wondering what we might have learned if we had been bolder, if we had been willing to take the risk and reach out. And so there is a growing chorus of voices, scientists and engineers and entrepreneurs and citizens who are saying, we should go, we should send a mission, we should find out. And this chorus is being amplified by social media, by online petitions, by op-eds and documentaries and public talks. And the pressure is building. And it is possible that the pressure will become strong enough to force a decision to compel the space agencies to act. And if that happens, if a mission is approved and launched, then 3I Atlas will have achieved something remarkable. It will have inspired humanity to take a leap into the unknown, to venture beyond the familiar, to seek answers to the biggest questions we can ask. And that alone, regardless of what the mission finds, would be a legacy worth celebrating. And as we approach the final hours before perihelion, as the telescopes make their last observations before the sun's glare overwhelms the signal, there is a sense of climax, building a sense that we are living through a moment that will be remembered. And there is also a sense of humility, because we are confronting the limits of our knowledge, the boundaries of what we can understand with the tools and concepts we have. And those limits are real, and they are frustrating, but they are also an invitation to go further, to build better tools, to develop new concepts, to expand the boundaries. And 3 Atlas is showing us where those boundaries are, and where we need to push, and whether it is natural or artificial, whether it is a comet or a probe, it is serving a purpose. It is teaching us. It is challenging us. It is forcing us to grow. And in the end, that might be the most important thing, because the search for extraterrestrial intelligence is not just about finding aliens. It is about becoming the kind of civilization that is capable of ending them, capable of understanding them, capable of engaging with them. And that requires not just technology, but wisdom, not just instruments, but ethics, not just data, but imagination. And 3I Atlas is a test of all of those qualities, a test of whether we have the wisdom to interpret ambiguous data responsibly, the ethics to share that data openly, the imagination to consider possibilities beyond our experience, and the courage to act on our conclusions even when the stakes are high and the outcome is uncertain. And so, as the object hurtles toward perihelion, as the final observations are made, as the scientists compile their reports and the public watches and waits, we are all participants in this test, all stakeholders in this moment. And the question is not just, what is 3I Atlas, but who are we? Who do we want to be? What kind of species do we want to become? And those questions have no easy answers, but they are worth asking. And 3I Atlas, making us ask them. And for that alone, it deserves our attention, our respect, and our thanks, because it is a gift from the cosmos, a messenger from the deep. Whether natural or artificial, whether random or deliberate, it is here, and it is real. And it is ours to study and to learn from and to wonder about. And when it disappears behind the sun in just a few days, when the observing window closes and the data stops flowing, we will be left with our questions and our theories and our hopes and our fears. And we will wait for it to re-emerge. And when it does, we will see whether it has changed, whether perihelion has transformed it or revealed something new. And even if it emerges unchanged, even if it continues on its trajectory and fades into the darkness and becomes just another entry in the catalogs, it will have changed us. It will have expanded our sense of what is possible. It will have shown us that the universe is stranger and more wondrous than we imagined. And that is enough. That is more than enough. Because the purpose of exploration is not to find answers, it is to learn how to ask better questions. And 3, Atlas has given us. The best question we could ask: are we alone? And even though we do not yet have the answer, the fact that we are asking it seriously, rigorously, passionately, is a sign that we are ready, or at least becoming ready, for whatever the universe has to teach us. And so we watch, and we wait, and we hope, and we prepare for the moment when the answer comes. And when it does, whether it is the answer we expected, or the answer we feared, or the answer we never imagined, we will face it together. As a species, as a civilization, as fellow travelers on this small blue world, hurtling through the vastness of space and time. And perhaps that is the real lesson of 3, Atlas. That we are all in this together, that the questions that matter are the questions we all share. And that the search for meaning, for connection, for understanding is what makes us human, and what might one day make us more than human, make us cosmic, make us part of the great conversation that might be happening out there among the stars. And 3, Atlas might be the first word in that conversation. Or it might be a false start, a misunderstanding, a reminder that the universe does no owe us easy answers. But either way, it is a beginning, and beginnings are precious and rare and worth celebrating, because they are the moments when everything changes, when the old certainties fall away and new possibilities emerge. And we are living through such a moment right now, and we should savor it and honor it and rise to meet it with everything we have, because opportunities like this come once in a lifetime or once in a civilization, and we do not get to choose when they arrive. We only get to choose how we respond. And so the question is not, what is 3, Atlas? The question is, what are we going to do about it? And the answer to that question will define us, will reveal who we are and who we aspire to be. And there is no right answer. There is only our answer. The one we choose together through our actions and our priorities and our courage. And as the countdown continues, as perihelion approaches, as the moment of truth draws near, we have the chance to choose wisely, to choose boldly, to choose in a way that future generations will look back on with pride and say, that was when we became an interstellar species. That was when we stopped looking inward and started looking outward. That was when we took our place among the explorers and seekers and dreamers who have always wondered what lies beyond the horizon and who have always had the courage to find out. And 3, Atlas is our horizon, And perihelion is our moment. And the choice is ours.